Let's learn the general method to draw any regular polygon given the length of one of its sides. Let's start by drawing a straight horizontal line at the bottom of our screen. So now, on the left side of this line, we are going to mark a point A. We are going to set our compass to the given length L on the top left hand side of our screen and transport this length to onto our line, setting our compass on point A and scribing an arc to form point B, as can be seen here in the video. So now we have our line segment AB, which will be the base of our polygon. So now we are going to draw a regular hexagon given the length of one of its sides L. The next step, with our compass set on the point A and radius AB, we draw an arc to the left. With the same radius and our compass set on point B, we scribe an arc to the right, which will intersect our previously drawn arc at point 0, which is going to be the center point of the circumference we are going to circumscribe our hexagon. So here we can see our circumference. To continue using the given measurement of the side L, which is the same as the radius of the circle, setting our compass on point B, we will scribe an arc to the right to cut the circle, which will be the next vertex of our hexagon. So now we are going to continue this process, marking the rest of the vertices of our regular hexagon. So as can be seen here, we set our compass on our previously scribed arc and scribe the next arc. And again, setting our compass on the previously scribed arc, we scribe our next arc. And if we have been working with accuracy, our last arc should cut point A exactly, as can be seen here in the video. It's not strictly necessary to draw this hexagon, but as it's our first time drawing this general method, it will help us to better understand it. Thereafter, there will be no need to draw the hexagon. So following on from this, we will join our vertices using a set square or ruler to complete the hexagon. So here we can see our 45-degree set square we use to join the vertices. And finally, we join the last vertices to point A to complete our hexagon. So now that we have the hexagon, the next step is to draw a line perpendicular to our side AB and through the center 0 of our circle. And we will prolongate this line above and below the circle, as can be seen here in the video. Where this line cuts the circle below the side AB, we will call this point T. Now the next step is to divide the radius OT into 6 equal parts using Thales' theorem. The first step is to draw a line starting from point T on the circle at any angle as shown here in the video. Now, using our compass, which we will set to a certain length, 1 centimeter or 2 centimeters, and we will proceed to scribe 6 arcs on this line using the compass as shown in the video. We can also do this using a ruler. There's our third arc, now our fourth. Now we scribe our fifth arc. Here you have the sixth division. Theoretically, we are finished, but we are going to continue scribing another 4 arcs. We will explain this motive later on in the exercise. So now we will proceed to mark 4 more. Arc 7, And finally, the last arc, 10. So now we have 10 arcs. We are now going to number each of these arcs from 1 to 10, as can be seen here in the video. Now the next step is to join the 6th arc to point 0 on our radius OT as shown. And from now on, we will draw parallel segments to the previous junction as shown in the video through successive marks drawn below previously. To do this, I use a 45-degree set square with a protractor in its center with the software we use to record these videos. But you should do it with a 45-degree and a 90-degree set square. These parallel lines will divide our radius in 6 equal parts as shown. And we will continue the process marking 4 more parallel lines above from point 7 to 10. So here we have our 7th parallel, our 8th, our 9th, and finally our 10th parallel. These extra 4 divisions, we will name them C7, C8, C9, and C10, as can be seen here in the video. C7 would be the center point of a 7-sided polygon with side AB. Furthermore, C8 would be the center point of an 8-sided polygon with the given side AB, and the same goes for points C9 and point C10. And conversely, the points below the origin 0, which would be called C5, C4, and C3, would also be the center points of a 5-sided, a 4-sided, and a 3-sided polygon, given the length AB. And with this method, we can draw polygons with any amount of sides. Normally, all the parallel lines we have drawn in today's example are not necessary. This is just to show you the method. The only parallel lines necessary are the 6th one and the number of sides of the polygon you wish to draw. In today's example, we are going to draw a 9-sided polygon, so the center point we'll be interested in is C9. So now, with our compass set on point C9 and length C9A or B, we will draw the circle, as can be seen here, which passes through both points A and B. If we have been working with accuracy up to this point, the length AB should fit into our circumference exactly 9 times. So now with our compass set to the length AB, we are going to scribe 9 arcs onto our circumference. It can be noted that in all odd-sided polygons where the vertical diameter intersects the circumference, this point will always be a vertex. So this can tell us if we are working with accuracy or not. So here's our 4th arc that we're going to scribe. And now with our compass set on the previously scribed arc, we scribe our 5th arc, which passes through our perpendicular line exactly, which tells us that we are working with accuracy. Now we continue scribing our 6th arc. Our 7th. our 8th, and finally our 9th arc should cut exactly through point A if we are working with accuracy, as can be seen here in the video. So now we have all the 9 vertices of the polygon, and we will proceed to name them A, B, C, D, E, F, G, H, I. And now we will join them to complete our 9-sided polygon. So we join from A to B using our set square or our ruler, from C to B, joins from D to C, from D to E, from E to F, from vertex G to F, from G to H, from H to I, and finally we will close our 9-sided polygon by joining vertices A to I. So now we have our 9-sided polygon given the length of one of its sides. I hope this video has helped you. Thank you very much. Please subscribe to our channel or click like. Thank you. Hello, let's draw an equilateral triangle given the measurement of one side. As you can see on the top left of our screen, we have this given line segment which is equal to the side A, which is equal to side B and also side C, as all the sides of an equilateral triangle are the same. Let's start by drawing a horizontal line, as can be seen at the bottom of our screen. Now we will mark a point on uppercase A on the left side of this line, which will be the first vertex of our equilateral triangle that we are going to draw. So now we set our compass to the length of the given line, and we will transport this line segment onto our previously drawn horizontal line. Setting our compass on vertex A, we will scribe an arc to the left, cutting a horizontal line on point B, which will be the second vertex of our equilateral triangle. Now repeating this process with our compass set to the same length and set on point B, we scribe an arc to the left until we intersect our previous arc at point C. This will be the third vertex of the equilateral triangle that we are looking to draw. So now we have the 3 vertices of the equilateral triangle that we are looking to draw with equal sides and equal angles. As the sum of the angles in every equilateral triangle equals 180, therefore the angles in our equilateral triangle must each measure 60 degrees. Finally, we will name the 3 sides of our equilateral triangle. We always use uppercase letters to name our vertices, and we always use lowercase letters to name the sides opposite the vertices, as can be seen. Hello, today we are going to draw a square given the measurement of one side. So the first step we are going to do is to draw a horizontal line at the bottom of our screen, as can be seen here. And on the left side we are going to mark a point A, which will be the first vertex of our square. So the next step, setting our compass to the given length L, we are going to transport this onto our horizontal line by setting our compass on A and scribing an arc to obtain our second vertex B, as can be seen here. So this is the first side of the square that we are going to draw. So the next step is to draw a perpendicular line going through point A. And to do this, we are going to use the 4-arc compass method. So we set the compass to any radius, and we are going to draw 4 arcs with this same radius. First, centered on point A, we draw an arc to the left, which cuts our horizontal line at point 1, as can be seen here in the video. So now, with the same radius and our compass set on the new point 1, we scribe an arc to the right, cutting our previously drawn arc at a point which we will call 2. And again, setting our compass on the new number 2, we scribe an arc to the right, cutting our original arc at a point 3. And as can be seen here. And finally, setting our compass on the new point 3, we scribe an arc to the left, cutting our previously drawn arc at a point we will call 4. This is called the 4-arc compass method to draw a perpendicular line. And finally, we draw a line from A through point 4. So now, setting our compass to the length L, and setting it on vertex A, we scribe an arc to the left until it cuts our perpendicular line at a third vertex on our square, as can be seen here. Now, setting our compass on the vertex B, we scribe an arc to the right, as can be seen here. And finally, with the compass still set to the same length and setting it on the previously drawn vertex, we scribe an arc to the left until it cuts our previously drawn arc, as can be seen here. And where these arcs intersect will be the fourth and final vertex, which we will call C, as can be seen here in the video. And finally, we name our other vertex D. So the final step is to join the 4 vertices with a thicker line to show our square. So from A to B, and now from C to B, from D to C, and finally we complete our square by joining vertex A to D. So here we have a square given the measurement of one of its sides. I hope this video has helped you. Please press like or subscribe to our channel. Thank you. Hello. Today we're going to draw a regular pentagon given the measurement of one of its sides. The first thing we need to do is to draw a horizontal straight line, as shown. On the left side of this line, we will mark a point A. Now, set the compass to the length of the side of the pentagon that we want to draw. And scribe an arc to get point B as shown. This will be the first side or the base of our polygon. Now we need to draw the perpendicular bisector of the base AB. To do this, I remind you we must Draw two arcs with the same radiuses. These radiuses must be longer than half of the base as shown in the video. And then the second arc with the compass positioned on point B. This arc will cut the first arc in 2 points as shown in the video. The perpendicular bisector is the line which passes through these 2 points. So let me remind you of the definition of the perpendicular bisector. This is the perpendicular line which passes through the midpoint M of the line segment AB. Okay, so now let's draw a perpendicular line starting from point B. And this line must be longer than the segment AB. Now let's scribe an arc of the length AB on this previously drawn line as shown in the video. And where this arc intersects our line, we will call this point P. So the next step is centering our compass on point M and radius MP. We scribe an arc to the right until it intersects the prolongation of the segment AB, as can be seen on the video, and we will call this point Q. So the length AQ will be equal to the diagonal length We will continue to draw our pentagon. Step 1, with our compass centered on point A and radius AQ, we must scribe an arc which just passes the bisector as shown. Now we repeat this process with the compass centered on point B until the two arcs intersect, as can be seen in the video. And we will call this point D, which will be the highest vertex of the pentagon. Now we must locate the other vertices of the pentagon. To do this, we must scribe two arcs of length AB, which will intersect our previously drawn arcs. Now we repeat this process with our compass centered on point B and scribe an arc to the right until we intersect our previous arc as shown in the video. So now we call these 2 points C and E respectively. So now we have the 5 vertices of our pentagon: A, B, C, D and E. The next step is to join these vertices using our set square to complete the pentagon. So C to D, vertices D to E, and finally we complete our pentagon from E back to A. So now we know how to draw a regular pentagon knowing the length of one side. I hope this video has helped you. Thank you. Hello. Let's draw a regular hexagon or six-sided polygon giving the length of one of its sides. The regular hexagon is the only regular polygon that the side is equal to the radius of its circumscribed circle. Let's start by drawing a straight horizontal line at the bottom of our page. So now, on the left side of this line, we are going to mark A. Now we are going to set our compass to the given length and transport this length to our line, setting our compass on point A and scribing an arc to form point B, as can be seen here on the video. So now we have our line segment AB, which will be the base of our hexagon, and we will highlight it with a thicker line. The next step, with our compass set on point A and a radius AB, we draw an arc to the left. as can be seen here in the video. Now, with our compass set on point B, we will draw another arc to the left. We scribe an arc to the right, which will intersect our previously drawn arc at point 0. Up to this point, we have followed the exact same steps to draw an equilateral triangle given the length of one side. But in this case, the top vertices of our triangle is going to be the center point of the circumference we are going to circumscribe our hexagon. As can be seen from the video, the radius has the same length as the given side of the hexagon. To continue, using the given measurement of the side, which is the same as the radius of the circle. Setting our compass on point B, we will scribe an arc to the right to cut the circle, which will be the next vertices of our hexagon. Now, setting our compass on this point, we will scribe another arc, which will be the fourth vertices of the hexagon. We continue marking our vertices by setting the compass on the previous vertices as shown here. We scribe our second last vertices. So if I'm working with accuracy, the final point should join exactly with the first point A, as shown here in the video. So now we will mark all our vertices A, B, C, D, E, and F. So now all that's left to do is to join our vertices to complete the hexagon so that we are looking to draw. So A to B, B to C, C to D, now D to E, vertex E to F, and finally we can close our hexagon, joining vertex F back to A. Here we have the hexagon that we are looking for. I hope this video has helped you. Thank you very much. See you in our next video. Hello, let's draw a regular heptagon given the measurement of one of its sides, as can be seen here in the top left hand side of our screen. The first thing we need to do is draw a horizontal straight line in the center of our screen, and on the left side of this line we will mark a point A. Now set the compass to the length of the side of the heptagon that we want to draw and scribe an arc to get point B, as shown here. This will be the first side or the base of the polygon that we want to draw. So the next step is from point A, we need to draw a line at an angle of 30 degrees. We can do this using a protractor or a 30-60 degree set square. As you can see here in the video, we use a set square with an incorporated protractor. So to continue, we draw a perpendicular line from the point B, which will intersect our previously drawn 30 degree line at a point N, as can be seen here in the video. So the next step is setting our compass to the length AN. We scribe an arc to the left, as can be seen here. The next step is to draw the perpendicular bisector of the given length AB. To do this, I remind you we must draw two arcs with the same radiuses. These radiuses must be longer than half of the base, as shown in the video. And now we will draw the first arc with the compass centered on point A. and then a second arc with the compass centered on point B. These arcs will cut each other above and below the line. The perpendicular bisector is the line which passes through these 2 points. And this perpendicular bisector is going to intersect our previously drawn arc at a point which we call O. And this point O is going to be the center point of the circle that we are going to inscribe our heptagon. So now we are going to draw the circle, as can be seen here in the video. Now the next step, setting our compass to the length AB, we are going to scribe 6 arcs around the circumference. So here, setting our compass on point B, we scribe our first arc. And now setting our compass on the previously drawn arc, we scribe our second arc. Again, setting our compass on our previously scribed arc, we draw our third arc. Again, setting our compass on our previously drawn arc, we scribe our fourth arc. And now our fifth. And if we have been working with precision and accuracy, our final sixth arc should cut exactly with point A, as can be seen here. So it cuts exactly with point A. This tells us that we have been working with accuracy. And the next step now is to name all of our new arcs, our vertices. So A, B, C, D, E, F, and G. And finally, to complete our heptagon, we join our vertices A to B, B to C, C to D, D to E, E to F, F to G, and finally we complete our heptagon, joining vertices G to A. So here we have our heptagon given one of its sides. I hope this video has helped you. Please press like or subscribe to our channel. Thank you. Hello, today let's draw a regular octagon given the length of one of its sides L. The first thing we are going to do is to draw a horizontal straight line at the bottom of our screen. On this line we will mark a point A, which will be the first vertex of our octagon. Now we are going to transport the given length L on the top of our screen onto our previously drawn horizontal line. With our compass set on point A, we scribe this length, and where it cuts the line, we will call this point B, as can be seen here in the video. Now we have the first side of our octagon located. The next step is to draw the perpendicular bisector of the line segment AB. To do this, I remind you, we must draw 2 arcs with the same radiuses. These radiuses must be longer than half of the line segment AB, as shown here in the video. These 2 arcs intersect at 2 points. The perpendicular bisector is the line which passes through these 2 points and cuts the line segment AB at its midpoint, which we will call M. So the next step is, with our compass centered on midpoint M and radius MA, we will scribe an arc to the right until it cuts the perpendicular bisector at a point we will call N. Now, with our compass centered on point N and radius NA, we will scribe another arc to the right until it cuts the perpendicular bisector again at a point which we will call O, or 0. This point O will be the center of the circumference, where the octagon we are looking to draw is. So now with our compass centered on point O, we will draw the circumference with radius OA or OB, as it will pass through both of these points if everything has been drawn accurately up to this point. We are close to finishing the exercise. The last step we need to do is set our compass to the length L or side AB and scribe 7 arcs onto our previously drawn circumference, as can be seen here in the video. So here we scribe our first arc. On our next one. Again, we scribe our next arc. We scribe our next arc again. We scribe our second last arc. I remind you to be as accurate as possible, placing the compass exactly on each point. Okay, and finally, our arc should cut exactly with point A if we are working with precision. Possible reasons that you don't cut the point A exactly: maybe you have lost precision because of the pencil of your compass is not well sharpened, or bad quality instruments. Now we have the 8 vertices of our octagon, which we will name A, B, C, D, E, F, G, and H. And the only thing left to do is to join these vertices. So now we will join point B to C, C to D, D to E, E to F, vertex F to G, G to H, and finally we will close our octagon by joining H to A. I hope this video has helped you. Thank you very much. See you in our next video. Click like or subscribe to our channel. Thank you. Hello, let's draw a nonagon or a 9-sided regular polygon given the length of one side. The first thing we need to do is to draw a horizontal straight line at the bottom of our screen, and on the left side of this line we will mark a point A. Now set the compass to the length of the side of the nonagon that we want to draw and scribe an arc to get point B as shown here. This will be the first side or the base of the nonagon we want to draw. So now, setting our compass to the length AB, we are going to scribe 2 intersecting arcs, which will give us the third vertex of the equilateral triangle, which we will call 1, as shown here in the video. Where the 2 arcs intersect, we will call this point 1. So the next step is to draw the perpendicular bisector of the side AB. So we set our compass to the length slightly more than half and we scribe 2 arcs as can be seen here. And now we scribe our second arc, cutting the previously drawn arc. Now we draw a vertical line through the two previously drawn intersecting arcs, as shown here. So the next step is to complete the equilateral triangle joining vertex A with vertex 1. The next step is we do a perpendicular bisector of the side 1B using the same process as we did with the side AB, as can be seen here. Again, setting our compass slightly longer than the length 1B, we draw or scribe two intersecting arcs. Now, setting our ruler on point A, we draw a line through the intersecting arcs. This line cuts the line 1B at a point which we will call M, as shown here. The next step is to set the compass to the length 1M, and centering the compass on the point 1, we scribe an arc until it cuts the vertical line at a point which we will call O, as can be seen here. And this point O is going to be the center point of the circle that our nonagon is going to be inscribed inside. And now centering the compass on this point O, and with length OA, we draw a circle as shown here. So now, setting our compass to the given length AB, we are going to divide our circle into 9 parts, which will be the vertices of our nonagon. I remind you that this method is an approximation method with an error of about 5%, which is fine for drawing by hand. So now, as you can see, we scribe our fourth arc, cutting the circle, and we continue setting our compass on the previously scribed arc. And we cut the circle again. If we are working with precision and accuracy, we should cut the arc exactly where the vertical line cuts the circle, as can be seen here. And we continue the process. Again, setting our compass on the previously scribed arc and scribing the next arc. And now the second last one. Okay, and again, if we've been working with precision, our final arc should cut at the point A. The next thing is we will name our arcs A, B, C, D, E, F, G, H, and I. And our final step is to join the vertices of our nonagon. F to G, G to H, or H to G. We do this using a darker colored HB pencil. We continue joining the vertices. I back to A. A to B, our base again. B to C. vertex D to C, D to E, and finally we close our nonagon, our 8-sided polygon, regular polygon, E to F. So I hope this video has helped you. Please press like or subscribe to our channel. Thank you and see you next time.